Good morning. I'm Libby Roop. I'm a partner in Deloitte's automotive practice. I focus on solutions related to product quality and safety. So today I've been asked to help moderate this panel as we want to talk about reliability. And we want to talk about how vital it is to brand reputation, customer decisions, warranty costs, and many more things. And given the amount of data that's being generated by modern vehicles, there's a real opportunity here to use that data to enhance development, enhance testing, and really overall enhance the customer experience. But that won't be possible without collaboration across the industry and really being able to integrate the physical product with the digital product. So without further ado, we've got a great panel of experts here that we can hear from. So I'll start with some introductions. So first we've got Ross Garrett. Ross is the VP and General Manager for Volkswagen Group's Cloud Division at CARIAD. He leads the next-gen connected vehicle platform, delivering new in-vehicle experiences, such as in the Audi Q6 e-tron, as well as the new Porsche e-Macan.
Great to be here.
Thank you. And we've got Norm Marks as well from NVIDIA. Norm is the VP of Automotive at NVIDIA. He leads the go-to-market for automotive enterprise business focused on autonomous vehicles, digital twin, and AI as well as GenAI. Thanks for being here, Norm.
Yeah, thanks for having me.
And rounding out the panel, we have my fantastic colleague, Chris Ahn. He leads Deloitte's software-defined vehicle practice in the US, which spans solutions for building software-centric solutions and architectures, and also driving strategy for enterprise development. So thanks, Chris.
Thanks, Libby.
So given this topic, Ross, I'd really like to start with you on this. So vehicles today are practically data centers on wheels. How is CARIAD working to leverage this data to really develop and deploy stronger products, as well as to respond to your customers' want?
Yeah, it's a great question, and I think, all automakers today are leaning into the collection and analysis of data. And so I think there's maybe 4 key areas that are important as we think about this. First is how we use data to create more contextual and personalized experiences and tailoring our products to each individual customer. Another thing is how we actually use data-driven insights to improve our products and allow our partners in the supply chain to improve their products as well. Getting usage data and other aspects of vehicle data has been really key. And actually, you've probably all heard the stats, something like 25 gigs per day could be generated from a typical car driving around today. And then the other areas would be around improving our software quality, right? So the key focus of what we're talking about here today, by understanding different usage scenarios, testing scenarios, and ultimately using the data that we collect to improve our software processes and make it easier for us to automate some of the testing that's so critical to overall software quality. And then finally, we've got things like direct monetization, of course, because data is really a new way to harness the information that we create as our customers and our vehicles drive around. So there's a huge plethora of ways which data has become very integral to how we develop software and how we ultimately build products end to end.
Thank you. I appreciate that. And I thinking about how you mentioned the fact that you're trying to build experiences that are unique to unique customers. I'd love to double click into that a little bit around what customers are prioritizing. So Norm, as we think about how the competitive landscape is really starting to shift with autonomous vehicles, what do you think the future of brand loyalty looks like? And how does AI and GenAI play a part in helping OEMs stay competitive?
Yeah, thanks for that. Safe harbor, my personal point of view on this. What I think we're seeing, and it's influenced by the market reaction, is that, loyalty of the past was focused on the quality of the vehicle itself or the driving experience with it. But quality played a large role in loyalty. In particular, most households have more than one vehicle in the garage. I think where we're seeing the future, the first impact on loyalty will be your confidence with the autonomous driving experience itself. If you've got two vehicles in your garage at home and one has full self-driving or autopilot or any other level of autonomy, and you have a wonderful experience with it and the other does not, I think we're going to see a huge shift in loyalty that second vehicle will likely be replaced by the brand that is providing that autonomous drive and an experience that you feel comfortable, confident, and safe with. So I think this is really going to be a huge shift from the quality of the vehicle itself to the actual autonomous driving experience. The second impact on loyalty that I think we'll see will come with your experience in the cockpit. We are already seeing AI cockpits of the future that are providing capabilities far beyond what you would expect. And with the move towards agentic AI, I think the expectations of first passengers in the vehicle and then eventually drivers will be so heightened in terms of the expectation of how do you interact with the passenger, the driver of the vehicle. And when we begin to have agents who are assisting us throughout our lives, and we're going to have avatars in the vehicle that can be assisting us, if you as a brand are behind in this and you are not providing that AI-driven interactive experience, I think that's the second big impact. So if you're not leading with autonomy and if you do not have an AI cockpit of the future, I think you are putting loyalty at risk. Saying it that way, on the flip side, the ones who are leading, I think, have a terrific opportunity to drive that experience. AI is just completely changing the expectations that we as consumers have. We expect to be treated as someone who knows us, and AI will get us there. And again, as I said, I think agentic AI and the move towards this is going to heighten expectations. We're going to have these co-pilots at work. We're going to expect to have the exact same experience with us when we're in the vehicle.
Yeah, I agree. And I think that, as you said, things are evolving so quickly. So when we think about the shift going from a hardware-defined approach versus a software-centric approach, this shift is going to be really complex. So Chris, you've supported players really across the ecosystem on their complex journey, moving from hardware to software-centric. So what are some of the opportunities that you see here for OEMs?
Yeah, so before I answer the question, the thing that Norm talked a lot about autonomous vehicles, and we just use that feature. This is one of many features that somebody experiences in their vehicle, and we decompose that. We're talking about a system for steering, we're talking about a system for propulsion, a system for braking or anti-lock brakes, a system for suspension handling, and all of that kind of culminates to a feature of autonomous driving experience. Well, today, all of those things, there are a lot of mechanical components that make that happen, right? And so in a hardware-based world, for that system, that complex system to orchestrate itself in a way that provides a desirable experience for a customer, it requires a lot of orchestration of suppliers, of the software developers of those suppliers, of compute power to be able to organize all of the development that happens from those suppliers. And so in a software-centric world, right, where software is actually leading that feature and it's not the hardware that's capacitizing the feature, you can design your hardware in a way that creates a lot more efficiency and scale, because software is actually going to be the component that creates personalization going forward, right? And I think that's the opportunity from moving from hardware to software that sometimes get overlooked. It's not just that software can bring a lot more cool experiences in, but it really has impact to the bottom line. You can reimagine how you buy parts. You can reimagine how you architect across models of vehicles, so you're not having to redo all the time. You can reimagine how you manage the cost cost structure of a bill of materials for an OEM. And all of this leads to vehicle profitability and or affordability for a customer, which is the #1 barrier to EV adoption today, right? And so I think there's a lot of opportunity to moving to software, to a software-first mindset for OEMs in going to that transition that transcends increased customer experience, which is certainly a very, very significant part of loyalty.
So given these phenomenal opportunities that you see, do you see challenges or roadblocks that could potentially prevent or slow down being able to capitalize on these?
Yeah, so like we're here at CES, and in the West Hall, there's a ton of cool technology here. And there's a lot of cool technology here from companies that are not automotive suppliers traditionally or automotive companies today, right? But to make all of that work together, it can't just be research and development of an automaker or engineering that drives that discussion. The rest of the business has to come along with it. Like a lot of the automakers that I work with are 100 plus years old. And for a majority of that history, they've been bending steel. I'm a little crass for it, but essentially discrete manufacturing and essentially, clicking parts together, right? In a world where software will continually update to improve our loyalty, to improve customers' loyalty to a brand, like the way that finance has to think about software-defined vehicles, the way the supply chain needs to think about software-defined vehicles, the way that IT needs to think about software-defined, all of that has to transform. It's not just R&D that's going to drive that change for an automaker, right? And I think that's one of the biggest challenges I see in the accelerating the adoption of this technology here that we see into traditional vehicles that we know of today, is that there's like a ton of energy that's getting spent at the technology level. And I am personally, my opinion is there's not enough education and campaigning that's done at the enterprise level. And that's really a focus area for us and my team, is we're really thinking about how do we break that barrier a little bit so that we can start accelerating the introduction of some of these technologies into our vehicle.
Yeah, so I love that, thinking about how you can help to move things forward. And I know, Ross, just even in some of our conversations earlier today, we were talking about some of the things that Cariad is doing to focus on that successful transition across various vehicle lines. So could you maybe speak to some of the best practices that you follow when building software competencies, and, as Chris said, companies that are traditionally more hardware focused?
Yeah, maybe I'll start with being a little bit provocative and say that, I think for automotive and many other industries, there has been this mantra that we must transform and become software organizations, that software is eating the world, and that everything needs to become a software company. I actually think that this has been terrible advice, and it's been poorly executed as well. It's just not enough context. You'll see headlines that say automaker XYZ just hired 10,000 developers, or plans to hire 10,000 developers, as if that was the measure of becoming a software organization, and it's quite simply not. And so I think the guidance that we're giving automakers today is flawed, and we have to rethink what we mean when we say becoming a software expert or becoming a software company. There are a variety of thought processes and development processes that embody what it means to be a successful software company, and we've got to think about that first and wrap it around a strong, what I call, product operating model. The examples that we've talked about even earlier today are that, for many automakers, this idea that software is a project that has that can be spec'd and costed and delivered and finished is what drives the problem. And it's also very tied, of course, to a waterfall approach to product delivery, right? Vehicles, by their nature, are quite waterfall-oriented in how we get them on the road. But software isn't, and it should not be, and we shouldn't tie the two together quite so tightly. So I think this is the first piece of the puzzle. We got to stop thinking like a project team that can finish a software project and simply put it on the shelf and move on to the next one. right? So we've got to think about a product, a platform first, and the products on top of it as something that that has a lifetime, that evolves over that lifetime, that we invest in constantly throughout its lifetime, that doesn't reach this sort of so-called finished state, which really doesn't exist, right? Software isn't finished, and it needs to be continuously optimized at the very least, even if it's feature complete. So that's the first big change, I think, that's super important. And so, as I said, organizations that really embrace this way of thinking, that bring software expertise into their organizations and try to drive that change from a mindset perspective, are those that can be successful. I will say that I'm a software person first, an automotive person second, so this has been an interesting journey for me personally as well. But I think that, you know, that's what's required. We got to invest in real good software and product thinking. And there's good examples, like we talked about updatability. The notion of updating software is so basic, so fundamental. If we talk to software people, cloud people, we talk to automotive people, and it's the most painful thing that they could ever do. And it's great to talk about this fantastic AI future, but we've still got to get some of the basics right. And so updatability is one of the key things that is still not as straightforward and robust as it should be. The notion that you know, we have this continuous integration, continuous deployment model in a true software context hasn't really made it to the car yet, and at least not in a, you know, totally pervasive, ubiquitous context. And that's because culturally, we talked about culture as well, organizations have found that it's actually hard, that software updates cause problems, and then they resist updates. They say, well, actually that one didn't go very well, so let's do them less often, right? This is like having gum disease and choosing to stop brushing your teeth, right? That is not the solution to the problem. We've got to deploy more often. We've got to you know, flex the muscle, exercise the muscle, get better at doing certain tasks, and updatability is certainly one of them.
Yeah, as someone who's spent 20 years in automotive consulting, I've had my fair share of seeing firsthand what you say, or what you said about waterfall versus agile development of software implementation, and you're absolutely right. It is a very difficult shift to go from the more traditional delivery of a vehicle to what software implementation would look like. And I guess, Chris.
Libby, if you don't mind,
Yeah,
just to build on some of his comments. First of all, yeah, software updates are not easy, but they're absolutely essential. To build on what I was saying, for autonomy, you can't just sit still with what you have today. As you continue to advance, and I'll protect the innocent, although obviously doing an amazing job, I have the pleasure, of course, of taking autonomous test drives very frequently. And I have the pleasure of some of our leading customers where I'll take them, and in 2 months' time, just 2 months' time, I can tell the difference. I can immediately recognize what they've done to advance the software, and I can feel it in the drive. And so we absolutely must continue to do this, and as we continue to move towards the advanced levels of autonomy, you'll see more and more of it. But even with the AI cockpits, again, to build on this, you know, today there's so much focus on voice AI assistance, open this, close that, and many other advanced features, but I really think, again, this expectation will be heightened and raised, and we are going to expect the vehicle to interact with us and be able to ask it questions around the driving. Why did you perform this way? Why did you make the turn? What should I expect? Well, you'll be able to actually have that conversation about the autonomous features, and then to further build on it, I mean, we're going to go from voice AI assistance to full integration with our apps, and we should be able to have these agents anticipate that we're going to be late for a meeting. Do you want me to start the Teams meeting for you in the vehicle, and so on and so on. And so we can't rest.
can't. You can't. And actually, it's a nice perfect circle there, right? Where we talked about data at the beginning and being able to, understand what our customers want and make improvements to our product and then redeploy based on that. Like that's that constant CI/CD cycle that we talk about as a holy grail to achieve. That's where we need to be, for sure.
So, Norm, if we stay on the topic of how things are evolving, when we think about just how rapidly the software is evolving, and as we shift from AV 1.0 to AV 2.0, the shift is actively happening. So how is NVIDIA collaborating on this shift with the automotive ecosystem to make this happen successfully?
Yeah, so first, perhaps I should at least give my version of what AV 1.0 to 2.0 is, because I'll bet if we ask 10 people, we get at least 7 or 8 different answers. And I'm not saying my answer is perfectly right, but to frame it, if we think about AV 1.0, think of this as 50 or more individual deep neural networks that are detecting something, detecting a vehicle, distance between, detecting the lanes, seeing a pedestrian, and so on and so forth. And of course, you can put these together as an ensemble of models to run, but they're built as individual DNNs. And by the way, they're also built on labeled image data. Now, that labeled image data is quite significant. A 50-car fleet will generate about 2 petabytes a day. So I know you were talking about this earlier, the scale. So the scale's quite hard. It's difficult to build these DNNs, and that's AV 1.0. We think about AV 2.0, and what we're actually seeing is a move from individual DNNs to one very large end-to-end world model that is trained on video data. And here we're seeing a huge, back to the question that Ross was asked, we're seeing model sizes of 13 to 20 times larger. We're seeing data set sizes of 17 to 30 times larger. We're talking about, running models on tens of petabytes of data to running models on hundreds of petabytes of data. And I'm seeing this quite consistently on a global basis with the companies that are leading the charge here. And there's a number of them. In fact, I'll be with one tomorrow morning. Wabi's doing some wonderful work in this space. But this move towards a world model, an end-to-end world model, is going to be hugely transformative. And of course, it'll be a journey, right? So, there's AV 1.0, there'll be an AV 1.5, where both are operating in the vehicle at one time, and one acting as redundancy for the other, and then learning from it. And then as these world models prove themselves, eventually AV 2.0, we will have these end-to-end world models be what gets us to the level of safe self-driving that frankly I think, as an industry we're all learning. In the early days, I think what we're now calling AV 1.0, we all felt would have given us the promise to get there. But I think we're now learning that these video models, the other piece I didn't really talk about is the differences in AV 1.0, you're detecting something. You're detecting a pedestrian. In AV 2.0, you're actually predicting the next frame. So the video model is actually predicting, will that pedestrian step off the curb? Will that vehicle make a cut-in? This is very different than detecting a cut-in or detecting a pedestrian who's moving off the curb, but actually predicting it. So huge transformation underway. This is non-trivial. Now, I can't help myself. Of course, I hope you saw the keynote and what NVIDIA is doing to advance the cause here with Cosmos, our new world foundation model, which again, I talked about really just real world data sets when I was mentioning model sizes earlier, but now the ability to create scenes that then you can use neural reconstruction to take one scene and have that become thousands of scenes. The ability to find those rare and dangerous corner cases, again, will go a long way. So much happening in the space.
Yeah, and as a vehicle safety person, I would be remiss if I didn't bring up the fact that it sounds like as we move to a more predictive, larger model, that it would really enhance the safety of the customer in the vehicle as well. Yeah. So I think when we think about talking about how most of these companies have been hardware-centric in the past, I think we probably have time for one more question. And Chris, I'd love to get your perspective on this, knowing really how many different groups you've worked with across this landscape. So we know that there are OEMs that are pivoting from hardware-centric to software, but there are also OEMs out there that are more starting fresh, clean slate, right, like auto tech players. So what do you see as the key difference between these two groups of players?
Yeah, I think a lot of it is, Ross hit it a lot earlier, in coming from a software-centric mindset, or leading with that versus a hardware-centric mindset is a very different philosophy. And just piggybacking on some of the stuff that Norma was just talking about, like in the software development world, there's this concept of site reliability engineering, right? Which is basically, let's go monitor and detect what's happening with my applications and my technology, and get in front of problems, right, before they actually happen, right? In the traditional auto world, these companies that have been manufacturing vehicles and servicing vehicles for 100 years, it's been the complete opposite of that. You wait for the field to tell you through a dealership network that I've got a bunch of these issues happening. And if there's enough collective information of these issues happening, then finally, this could be 8 months later, an automaker will find out, oh, I might have an issue with this. Then they got to close the loop back with research and development and engineering, say, hey, we got to fix this. But they're already in a production run, right? So they're going to fix it in the next model and then deal with the fixes in the field through recalls. So they have to call their suppliers. Like I can go on and on and on about this, but some of these things could take 2.5 years. Mm-hmm. In a software-first mindset, that same problem, you can say, can I fix that issue with software? And so then let me go over-the-air update, right, which is a difficult thing to do, but you can, over-the-update 2 million vehicles that are on the road. By the way, let me go over-the-air update the production run that's in the field already, because the modem I can turn on the second station in the assembly plant, right? So I can stop the bleeding going forward. I don't have to go and wait. But, right, so that's a big, there's a huge mindset shift when you look from a software-centric angle first to go build a vehicle, which is what I think a lot of the newer auto players have done, right? They've really thought through, how do I create the same mobility device, but use a totally different frame of designing and architecting, right? And that's a significant advantage, as I just described for service engineering, but, there's 5 or 6 other advantages that come along with that as well, right? So, we're talking about reliability and quality as, an average vehicle today has got 100 million lines of code in it, right? And it's developed by 300 different suppliers at any given point in time. If we get that right, if traditional automakers are able to get that right, there's so much advantage that you can have in the reliability space. There's not going to be such a huge blast radius of these issues that come along, and such a long wait time, which all accrues, like the warranty accrual costs and quality costs and all this stuff. That's the vision that we see, right? Is in a software-centric vehicle manufacturing world.
Yeah, thank you, Chris. I completely agree. Like I said, as someone who works in product quality and safety, all of the various tentacles that you have to go through once a problem is already out in the field can make a problem that, even if you've detected it in the first 1 or 2 months, it's still out there, and you've got to figure out a way to stop the bleeding, as you said, and prevent it from going into any of the other vehicles. So intimately understand that piece of it.
If you don't mind, it's terrific what you're talking about, but now imagine a future world where I have a digital twin of every single vehicle that's on the road, that I'm seeing what's happening with every single one of those vehicles, and I could potentially even flash something to the digital twin to see if, in fact, we can fix it, and prove it in the digital twin first, and then flash it to the actual vehicle itself. Now, this may seem far-fetched, but I actually spent 2 hours with one of our customers last night who is building this vision right now.
It's a big part of the cycle, for sure. It's one of the things that, if we think of it as a device shadow, right? We can see current state of a vehicle, even in its current space, in real time, and that gives us a huge opportunity to improve our software quality processes, our software development processes, from the ground up.
Well, I'd like to thank all of you for sharing the stage with me today and talking about this topic, and I hope it was helpful to everyone here as well, but thank you all.
Thanks.
Yeah, thanks for having us.
Thanks, everybody.